So, in business classes that you might take if you're a business major, marginal analysis is it's a biggish deal. It comes up quite often. I was an accounting major, so I spent a lot of time talking about marginal profit, marginal revenue, and marginal cost. Maybe didn't really recognize that they were related to calculus, but it didn't matter at the time. When I was a business major, you didn't have to take calculus. From 82 to 86, I went to NAU, and we didn't have calculus as a requisite for a business degree. Anyways, marginal profit's an important concept, even if you don't realize there's a connection to calculus. Marginal profit is the profit earned by selling one more unit. For instance, if Apple's selling whatever iPhone is available now, and right now their profit is $500 million. And when they sell one more phone, let's say they make $1,000 out that phone, now their total profit's $1,000. That extra $1,000 that they make by selling one more phone, that's the marginal profit. Or maybe a smaller situation. My mother's in a sewing club, and they every November, except when there's COVID, they sell items at a fair in Sun City, and they donate the money to some charities. Anyways, if they sell one more face mask, they're gonna make if they sell 100 face masks, they're gonna make $200. And when they sell the 101st face mask, they make an extra $3 when they sell that face mask. Marginal means the next. It's not the total profit. If my mother's sewing club made $200 by selling 100 face masks, but when they sold that 101st face mask, they made an extra $3 in profit, it's the extra $3 that took their total profit from $200 to $203. That's what marginal profit is. It's the extra profit when you sell one more item. It's the profit for selling one item. And to find marginal profit, it's the derivative of a profit function. If you have a profit function and you find its derivative, if you plug a number into the derivative, it will tell you how much more money you'll make by selling one more item. Marginal profit's the difference between marginal revenue and cost. Marginal revenue minus marginal cost is marginal profit. Marginal profit's a big deal because marginal profit is usually helps companies make production decisions. Even if the marginal profit for a product is 1 penny, meaning if you sell one more unit, you make a penny, you're still making money. Once the marginal profit goes negative, meaning the extra money that you make for selling a good is negative, then you're losing money. Then there's no need to sell anymore. Maybe start producing something else. So marginal profit is important because it helps you understand whether you can produce more or you need to contract production. If you're losing money on every additional product that you're selling, then why sell them? And if you're making money on every additional product that you're selling, might as well make and try to sell more. So under mainstream economic theory, a company will maximize profit when marginal cost equals marginal revenue, because profit is revenue minus cost. And when these things are equal, the marginal profit is zero. You're not making any more, but you're not leaving any money on the table. If you sell one more, if you make and sell one more, you start losing money. And if you did one less, you could have made one more unit of sales that you still made profit on. Marginal revenue is like marginal profit. It's the additional revenue when one unit is sold. One more unit is sold. Assuming like a new iPhone sells for like $1,200, the marginal revenue from Apple selling one iPhone is $1,200. It's the additional revenue that they're going to generate. And let's say it cost them $400 to produce that iPhone. The marginal revenue from selling one of those iPhones is one more iPhone is $1,200. The marginal cost is the cost to produce that one iPhone, maybe $400. In that case, the marginal profit would be $800, the difference of the $1,200 in revenue that I made up that they get for selling the iPhone, minus the made up $400 that it cost them to make the iPhone. I have no idea what the phones cost to make, but I don't think it's particularly, it's not that much money. I think there's a big profit margin on those. So I think that's probably enough to say about marginal profit. And let's look at a simple example. That keeps the number small but not ridiculously small. So it says a real estate agent, I don't know, a real estate company, it's got to be a real estate something, has a 100-unit apartment complex and it plans to rent out the apartments. The monthly profit generated by renting out X units is given by this. Maybe if they rent out all 100 units, well, they have to bring on extra staff, and they maybe will have more maintenance. Maybe they'll have to pay overtime. Maybe the maximum profit is not going to be by renting all 100 units. There's probably some optimal number of units to rent, but in this problem, we're asked to find the marginal profit function and evaluate the marginal profit function at 50. The marginal profit function will tell me how much additional profit I'll get by renting out the next unit. And if I evaluate the marginal profit function, which is the derivative of the profit function, when at 50 units rented, it will tell me how much extra profit I'm going to generate by renting out the 51st unit. This is ugly. So let me find the marginal profit function. The marginal profit function is simply the derivative of the profit function. So how do I find the marginal profit function? Well, I find the derivative. I need to create 2 points. So for part A, one of my points is going to be x for its x coordinate, and the right-hand side of the function, negative 10x squared plus 1760x minus 50,000 for its y. The next point, its x coordinate's going to be x plus h. And its y coordinate's going to be negative 10 times x plus h squared plus 1760 times x plus h minus 50,000. So to find the derivative of a profit function, you get a marginal profit function. I'm doing the same. I'm creating 2 points. One that has an x for the x, the other that has x plus h for the x. And now I'm going to find the y for that second point. And I'm using that sneaky fact that x plus h squared is x squared plus 2xh plus h squared. Got to be so careful, and even when I'm so careful, I mess up. So now let me clear the parentheses and get negative 10x squared, and then negative 10 times 2xh, negative 20xh, negative 10 times h squared and get negative 10h squared, positive 1760 times x and get positive 1760x, positive 1660 times h and get positive 1760h, and then minus 50,000. So this is just grungy, but it's nothing that I can't do. I'm creating 2 points. The first point is x coordinate is x, its y coordinate is the function that's given. The second point, its x coordinate is x plus h, its y coordinate is found by changing the y's in the function to x plus h. Now I have 2 points. I'm going to find the slope of the line that connects those 2 points and let the limit that goes to 0. So my marginal profit function, the function that will allow me to figure out how much extra money that I'll get by renting the 51st unit, my marginal profit function is the derivative of the profit function. So I'll put a little prime to mean derivative. It's going to be the limit as h goes to 0 of y2 minus y1. y2 is negative 10x squared minus 20xh minus 10h squared plus 1760x plus 1760h minus 50,000. And now I'm going to be efficient. After this, I'm supposed to do minus negative 10x squared plus 1760x minus 50,000. So this is what I'm supposed to put after in a parentheses this. But let me just delete the parentheses and clear the parentheses now and get positive 10x squared minus, I forgot the x here, minus 1760x plus 50,000. Okay, now let me clean up that numerator after I put an h in the denominator. So in the numerator, if it doesn't have an h, it should cancel. This minus 10x squared and that positive 10x squared cancels. This positive 1760h and that 1760x and that negative 1760x cancels. Negative 50,000, positive 50,000 cancel. I get the marginal profit function is the limit as h goes to 0. And in the numerator, there's 1, 2, 3 terms left. They all have an h. I'm going to factor out that h before I write the numerator. When I factor out the h from the minus 20xh, I'm going to be left with minus 20x. When I factor out the h from the minus 10h squared, I'm going to be left with minus 10h. And when I factor out the h from the 1760h, I'm left with 1760. I'm going to cancel the h's and get the marginal profit function, which is the derivative of the profit function, which is the function that tells me how much more money I'm going to make by renting out one more unit. Can be found by plugging in 0 for that h. The marginal profit function is negative 20x minus 10 times 0 plus 1760. So my answer to part A, the marginal profit function, is negative 20x plus 1760. This is the function that if I plug a number in for x, it tells me how much extra money I'm going to make by renting out one more unit. And it will tell me actually what unit. So the answer to part A, the marginal profit function, is negative 20x plus 1760. And in chapter 2, we'll learn how to go from there to there in about 2 seconds. Part B, take 50 and plug it into the marginal profit function and interpret my answer. So I'm going to plug 50 in and get negative 20 times 50 plus 1760. And when I plug 50 into the marginal profit function, I get negative 20 times 50 plus 1760. I get $760 in this case. So P prime, the marginal profit function evaluated at 50 is 760. And this tells me that when they rent out the next unit, they're going to make $760. So the additional profit, so an additional $760 of profit will be earned when renting out the next unit. So by renting out the 51st unit. So it's definitely worth their time to rent that out. If the marginal profit was negative, then it wouldn't be worth renting out that unit. To be losing money on renting it. All right. Hopefully we're at a time now where we can start doing some homework. And let's spill into two videos. Let me do problem 2. Problem 2 gives me the graph of a half a parabola, and it shows a tangent line. It says the tangent line goes through the point -2, 4, and I can tell that this tangent line also goes through the point 0, -4. I need 2 points to get the slope of any line. Part A wants me to find the slope of the tangent line, so I took the given point and then I searched. I can find any other point on this graph. I could have found the point -1, 0. I just chose the point 0, -4. I find 2 points, and I'm going to find the slope of the line between those 2 points. So for part A, the slope of this tangent line, I'm going to take the point -2, 4 and call it my first point. I'm going to do 0, -4 and call it my second point. It's going to be y coordinate of the second point minus y coordinate of the first point divided by x coordinate of the second point minus x coordinate of the first point. The double negative in the numerator, -4 minus 4 is -8. The denominator comes out to 0 plus 2, which is +2. I get -4 for the slope of the tangent line. My answer to part A, the slope of the tangent line, is -4. And if I want to evaluate the derivative at x equal to -2, if I plug -2 into the derivative, I'm going to get the slope of the tangent line, which is -4. Part A wanted me to use just generic algebra to find the slope of a tangent line. Part B wanted me to understand the relationship between slopes of tangent lines and values of derivatives. The x coordinate of the tangent line, if I evaluate the derivative at the x coordinate of the tangent line, I get the slope of the tangent line, which is -4. Plugging numbers into the x coordinates for derivatives, I get slopes of tangent lines. I don't think this is just viewable, so I won't have you, you can try to do, I think you can do it. It looks like problem 1. It looks like another point right there would be the point 1, 0. Maybe let's do 1 together and I won't do number 4. So let's find the slope of the tangent line. For part A of number 1, I need 2 points. I'm going to call the point 2, 4 my first point, the point 1, 0 my second point. The slope of my tangent line is going to be 0 minus 4 over 1 minus 2. That's going to be -4 over -1, which is +4. The answer to part A of number 1, the slope of the tangent line, is 4. For part B, the value of the derivative when x equals to 2 is 4. The value of the derivative at the x coordinate of the point where I found the slope of the tangent line is the slope of the tangent line. And that's all there is for that. I'll show 3 up on the screen just in case you want to give it a go. It looks like an extra point there might be the point 0, 1. It's not labeled, but you should be able to, if you can see this well enough, you should be able to figure it out. I'm going to skip 4 because I don't think these are particularly that hard to do so many of them. I will spend some time on these. So 5 and 6, 7, 8, 9 all want me to find the derivative, the equation to find the slope of the tangent line. So your 5 gives you this function. It wants to find its derivative in part A. In part B, it wants you to plug 4 into the derivative. My 5 gives me this function. I want to find the derivative of that function. And in part B, I want to plug 4 in. So in order to do my 6 part A, I need to create 2 points. The first point, its x coordinate's going to be x. Its y coordinate's going to be the x squared minus 5x plus 7. That's the freebie. The second point, its x coordinate's going to be x plus h. Its y coordinate, I have no idea what it is, so I'm going to do it off to the side. How do I find its y coordinate? I take both of those x's and change them to x plus h. So I go x plus h quantity squared minus 5 times x plus h plus 7. This guy comes out to x squared plus 2xh plus h squared. I'll use that over and over again. And then minus 5x minus 5h and still plus 7. So this y is x squared plus 2xh plus h squared minus 5x minus 5h and plus 7. Now I have my 2 points. I can find the slope of the line between the 2 points, take the limit as h goes to 0. So the derivative is found by taking the limit as h goes to 0 of y2, which is this x squared plus 2xh plus h squared minus 5x minus 5h plus 7, and then minus y1, which is x squared minus 5x plus 7. And instead of doing this in 2 lines, I'm putting the minus up high so I can clear the parentheses that I would naturally put in. Here I'm going to get a minus x squared plus 5x and minus 7. In the denominator, it's enough just to put h. In the numerator, every term that doesn't have an h should cancel. The x squareds cancel. The minus 5x and positive 5x cancel. The minus 7 and the plus 7 cancel. So in the numerator, I just have those 3 terms with an h. As I'm writing this down, I'm going to pull out my common factor of h and get the limit as h approaches 0 of h times 2x for that, and then plus h when I factor out an h from the h squared, and then when I factor out an h from the 5h minus 5 all over h. I'm going to cancel out the h's and get the derivative, which is the formula to find the instantaneous rate of change, which is the formula to find the slope of the tangent line, is the limit as h goes to 0 of 2x plus h minus 5. When I plug in 0 for h, I stop writing the word limit. My answer to part A is just going to be 2x minus 5. So for 6a, the derivative, f prime of x, is 2x minus 5. Part B just wants me to find f prime of 4. I'm just going to plug 4 in for the x's. So for part B, f prime of 4, which would give me the slope of the tangent line when x is 4, is 2 times 4 minus 5. That's going to be 8 minus 5. My answer to part B, f prime of 4, is going to be 3. And there's nothing more I need to do with it than just that. Let's do 7 together. So for 7, in fact, let's skip 7 and let's do 9 together. It's a little grungier. So for 9, I'm going to find the derivative, and let's find the derivative by finding 2 points. So I'm not going to do 10. I'm going to find the derivative, and then I'm going to evaluate it at 4. So for number 9, to do part A, to find the derivative, I need 2 points. My first point is going to be x, and then 3x squared minus 4x plus 2. And then x plus h, comma, and that comma is not pleasant, so let me figure out what that comma is. To do that comma, I'm going to go 3 times x plus h squared minus 4 times x plus h plus 2. This is going to be 3 times x squared plus 2xh plus h squared minus 4 times x plus h plus 2. So it's going to be 3x squared, and then 3 times 2xh plus 6xh, and then 3 times h squared plus 3h squared, and then minus 4 times x minus 4x minus 4 times h minus 4h, and then plus 2. Those are my 2 points. The plus 2 went off the screen, but I can bring it back. And now I'm going to find the slope of the line that connects those 2 points by doing the derivative is the limit as h approaches 0, y2, which is 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 2. And I should write minus in a parentheses 3x squared minus 4x plus 2. But I can clear that parentheses without actually writing the parentheses and get minus 3x squared plus 4x and minus 2, and then all over h. Now cancel the 3x squareds, cancel the 4x's, and cancel the 2's. Everything in the numerator that doesn't have an h should cancel. Now in the numerator, I'm going to pull out a common factor of h before I write down what's left. So pull out an h. The 6xh, when you take an h away, you're left with 6x. The 3h squared, when you take an h away, you're left with plus 3h. The minus 4h, when you take an h away, you're left with minus 4. Cancel the h's, and I get f prime of x is the limit as h goes to 0 of 6x plus 3h minus 4. I'm going to plug 0 in for h and stop writing the limit, so it's going to be 6x plus 3 times 0 minus 4, and that's just going to give me the derivative is 6x minus 4. So my answer to part A of number 9, the derivative is 6x minus 4. So for 9a, f prime of x is 6x minus 4. For 9b, it just wants me to find f prime of 4, and that's just plugging 4 in, or the derivative evaluated at 4. It's going to be 6 times 4 minus 4, which is 24 minus 4. The answer to part B is going to be 20. We have some grunge coming up for the problems 11 and 13, so I'm going to put those in another video. And then some equations of tangent lines and maybe a marginal profit. Yeah, so the next video looks long. Let me pause and we'll do a part 3. Hopefully not a part 4, but maybe a part 4.